All right, I have a series of vertical angle questions that I'd like to address with you. I think the overall process of vertical angles and the relationship that exists with them is not outside of our scope. I think we should, by now, after the few times we talked about it in class and then the full instruction I gave you yesterday of this, should be something we pick up on quickly. But the algebraic process that can generate in problems like this is going to be something that is pervasive through the rest of the class. Working with systems of equations and different strategies that we use to complete them is going to be very critical for being successful in this class. So I think this is an opportune time to take a little bit of class time and talk about how we solve systems of equations. So again, just briefly here with this question, number 11, we want to solve for x and y. So the options are, and I did this yesterday, I'm going to write down all the relationships that I know. So the most recent observation or relationship that we get per this section is that these two angles should be vertical, so they are equal to one another. They are congruent angles, so their measurements are equal. So we get something like that. Okay. Now there's also the relationship that this angle here and that angle there are a linear pair, so that means they are supplementary. So we're going to say 2x plus y plus x equals 180. And then we can do a similar thing with this green angle and that green angle and say that they are also supplementary. They form a straight line. So you go y plus x plus then y minus x equals 180. And as I'm going to kind of commence on this problem, what I want to do is just try to simplify things, just trying to make things real nice. I see I've got variables on both sides here, so I'm just going to move this x over. So I'll add x here and add x here. So it's going to be 3x is equal to y. Okay, this bottom, or not the bottom, but number 2 here, I can rewrite that as maybe 3x plus y equals 180. And then this final one I can rewrite as, we see that the x's actually cancel each other out, so I'm left with 2y equals 180. And we have the need now, because if I look at these first two equations, I might think, oh, that's a problem because there's two variables and I'm going to have trouble solving this. If I have two variables in an equation, in order to solve numerically for those variables, I need another equation that has the exact same two variables. So with these two, I could completely ignore this bottom one, and I could use this information in these two and solve this problem. If I did that, I'd be wasting a lot of my time, because right here we have a one variable equation, and that will yield right away that y is equal to 90. And if that's the case, then I can come up here and say, okay, I could do this in either one of this first equation and the second one, but I could say, well, if y is 90, then 3x equals 90, thus that leads to x being 30. Okay, so that's a situation where it's very similar to one of the examples I did yesterday, but it gives you I think the visual here that just the first two equations you come up with aren't always the best two to use in regards to efficiency of solving the problem. I created these two, and it took maybe another 10 seconds to create this one. And then because I created this one and spending a little, maybe 10 extra seconds to analyze which of these three equations is the best to deal with, I'm able to solve this question pretty quickly. But if I didn't come up with this last one, if I didn't analyze another relationship, and I just stopped at these two up here, and I'm left with 3x equals y and 3x plus y equals 180, now I have to understand how do I solve this system. And in this case, it probably sets itself up best for substitution, where if I see y equals 3x, everywhere down here where I see y, I can replace it with 3x. So then I get 3x plus 3x equals 180. I get 6x equals 180. And x is 30 then. Okay? Not much extra work, but I think it is longer than what we, it's more time consuming than what we came up with over here. But do I still get the same value for x? X was 30 there, x is 30 down here. Now, maybe substitute back up into that one, and I can get the result that if x is 30, so go 3 times 30 then is equal to y, so it gives me 90 is equal to y. So that's maybe one of the more basic ones, but that's a situation where, you know, coming up with the first equation and the second equation might lead me to a less efficient process in comparison to finding that third equation. So we're going to do the same thing here. If I got looking at the vertical angles, we got those two. So let's say y equals 2x. Okay. Now with this angle here and that angle there, those form a linear pair. So we say, I'm just going to combine everything right away. So I'd have 2y's plus 1x plus 5 equals 180. And if I want to combine these two, because they're a linear pair as well, so I have 3 total x's plus y plus 5 equals 180. Okay. So again, probably what would be the best thing to do, I'm going to look at my options here. Okay. And I'm going to go ahead and just kind of rewrite these two as 2y plus x equals 175 and y plus 3x equals 175. And this top one is obviously y equals 2x. I'm going to leave that one alone. Okay? So I'm going to go through. What would be nice here is if we just like had a timer here and just clocked ourselves on how long it takes to do this problem this way. And then make a comparison to, you know, what would it be if we maybe used equation 1 instead. But one approach to this is to be able to do elimination. Okay, so you have to decide, you know, what variable do I want to eliminate? Which variable do I want to cancel out? Okay, there's no wrong answer to that, if you remember from last year. But what you're going to try to do is try to get coefficients of these variables that line up on one another to be opposites. Okay, so I can either multiply the top one by -3, because if I did that, then these two coefficients here would be +3 and -3, and they would cancel out when I add down. Okay, or I can multiply this bottom one by -2, and then this equation and that one will have a +2 and a -2 for the y's, and they will cancel out. That's what I'm going to do. I'm going to multiply this bottom one by -2. So if I do that, so give me -2y minus 6x equals -350. Now what we like to do is we add straight down, and this is the idea of why this is called elimination. And those two should have eliminated. They should add to 0y. I now get minus 5x when I add straight down here. Remember, adding coefficients, okay? And then -175. Divide both sides by -5, and x ends up being 35 in this case. Okay. Once I know what x is, I can plug that back in up here, and I can plug back into any one of the equations that we had throughout any part of this problem. Okay, and I'll be able to then solve for y. So if I plug in, I'll plug in this blue one here. I would have 2y plus 35 equals 175. 2y then is 140. Y then will be 70. Okay. Algebraically, that means that if I were to graph that line and that line right there, they're going to graph the ordered pair of 35, 70. Let's do it this way. Let's say that, I had 2y plus x equals 175, and we had y plus 3x equals 175. Let's say I multiply the top by a -3 in this case. So if I do that, that top equation is going to turn into -6y minus 3x equals, now that's 350, so is that negative 525? Alright, so now so this top one is now, because I multiplied by -3 is this bottom, so I'm going to add these two together. Okay, so adding those two together, when I add straight down, I'm now going to get -5y. Now my positive 3x and negative 3x, they dissolve each other, eliminate each other, and now here you're going to get -350. Okay, well, divide by -5, divided by -5, gives me y equals 70. And that's exactly what we had previously. Eliminating the y's, I should get the same thing by eliminating the x's. Now that I have that, I should be able to go back up to this one of the beginning equations, and plug in that 70. So 2y would be 140 plus x equals 175. Subtract 140 from both sides. Again, you get x to be 35, which is exactly what we had there. Okay. Now those are two routes that 100% work. They're fine. Okay. But what if I took this equation and I don't know, I would maybe use this one here because it has one y in it, and use those together. If I go y equals 2x, and ultimately this would have been, 3x plus y equals 175. If y is 2x, I come down here and replace y with 2x. So that's going to generate 3x plus 2x equals 175. That's 5x equals 175. X then is 35. If x is 35, take that back up here, plug in, get y to be 70. So this is, we solved one problem, but I solved it, 4 different ways here, or 5 different ways, however many different ways. And we get back to 35 and 70 being the answer each time. I think it's a practice here that we see that maybe that one was the quickest. Okay, and if we can sit down and identify our 3 equations, or in some problems it'll be 4, 5, 6, 7 equations, and then see which ones work. Think before I do any work, see which ones are going to work the best together, and then set forth to do the math. Okay, but have a plan first. Don't just blindly approach something and have no idea. Okay, it's like, if you're gonna mow a yard, okay, let's say this is my yard. I'm gonna approach my yard, and I've got in my mind maybe a route that I'm gonna go. Maybe mow my yard kind of like that. Okay, some people might decide to mow the yard like this. Okay, but nobody would say, I'm going to mow my yard here and we'll come down here, and then there, and then over, and then over, and there, and then back here. Okay, you wouldn't mow that way because it's inefficient. You're missing a lot of area that you're gonna have to go back and touch up. Okay, same idea here. Okay, can I think of a plan first before I start working? So question 13, very similar to question 12. Let's do this one here, question 14. Again, we've got these vertical angles. Okay, so the relationships in all these problems are the same. These two angles here are vertical, so I can say 3x plus 8 equals 5x minus 20. Okay, that's a great equation because it allows me to solve for x right away. It's one variable. Let's go ahead and write the other equations. 3x plus 8, that angle there, and that angle there. And now we can look at, so they're a linear pair, look at these two, and say that they are a linear pair. I just like to number my equations here so I can talk about them a little bit easier with you. You don't necessarily have to do that on your own. Alright, so let's assume that we did this problem and we didn't come up with that relationship. We didn't have that one yet. Okay? Maybe these were the first two that we came across. I think most of you would agree that we can rewrite this as 8x plus 4y equals 172. 8x by adding those together. 4y doesn't have any like terms, and I move that 8 over there. This one gives me what, 10x plus 4y. So 10x, 4y, and then let's move this 20 to the right hand side equals 200. Okay, so in this instance I've got these two equations. They both have x and y in them, and I think, okay, well, my only option then is to use elimination. If I'm going to use elimination, let's make one of these. I think the y's would be best suited to cancel each other out because they're already the same quantity. We just need to make one of them negative. So I'm going to multiply everything by a negative in this top equation. Okay, if you remember back to last year when you worked with elimination, you had a rule that you're allowed to multiply either equation, top, bottom, or both, by any number you want. You just have to make sure that you do that to every single term. So I just multiplied by -1. So now I'm going to add straight down. So I'm going to add straight down -8 plus 10 is 2. This would have been a -4y. I don't know why those are disappearing. -4y, +4y, those eliminate. And then here, that's going to give me 28. So that gives me x to be 14. And now I can take that and I'm going to go back up to any equation that I started with. And I should be able to solve for y. I'm going to go to this one because I see I would rather multiply x by 4, just foreshadowing again, okay? Not just being a robot. I've got options. I can plug into that top one or the bottom one. And I look at where am I going to put x in? I'm going to put it right there. What kind of mental math am I more comfortable with? Would I rather multiply 14 by 8? Or would I rather multiply 14 by 10? If I got an option to multiply anything by 10, that's where I'm going to go. So I'm going to go 10 times 14 plus 4y equals 200. So it gives me 140 plus 4y equals 200. So it's going to be 4y is equal to then 60, and y would be 15. Okay. So I got my answer, 14, 15. Okay. And I think that was a lengthy process. Let's look at this yellow equation, which we assumed that we didn't have at the onset. Okay. Or we weren't paying attention to the cleanliness of this equation. But if I look at that, can I instantly take that 3x to that side So that'll lead me to 8 equals 2x minus 20. Add 20 to both sides, and that leads me to 28 equals 2x. And that will lead me to x equaling 14. That's exactly what we got, okay? But if we would have, we're still probably writing this stuff down here using this route on our way to getting this 14, okay? Now, because I've got x equals 14, if that yellow one was the only equation that I came up with, I don't have then the ability to solve for y. I still need one of these other two equations, either this blue one or this red one. And if I've got that blue one, let's just go with, what do we say? It was 8x plus 4y equals 172. We'll plug 14 in here, so 8 times 14 plus 4y equals 172. So 8 times 14. So this is where I didn't want to do this math, but 8 times 4 is 32. Carry the 3, add that to 8, so we get 112 plus 4y equals 172. Subtract the 112 from both sides, so we get 60. Y equals 15 again. Okay. So my argument to you again is the geometry is setting these equations up. Once you set those equations, you got those relationships, you've mastered the geometry. Now you have to be a thinker, and you have to foreshadow. You have to think, okay, what is going to be the best route to getting to a solution? Okay, and now what I think is kind of tricky is if you've mastered this, you've got the geometry, but you get these x and y values wrong, that tells me you got the whole problem wrong, and I can't really accurately judge how well you knew your geometry. Okay, so in order to be successful in demonstrating you know your geometry, you have to be proficient in your algebra. Okay, and that's something that we'll work on. We'll see throughout this course a lot of problems that deal with these systems of equations. Okay, so just kind of give you a rundown real quick of the types of algebra. So my personal opinion is that the geometry is great. The logic that we gain and the thought patterns that we gain in geometry is fantastic. But individually, the concepts standing alone are not all that difficult. Okay, so we have some time to learn or revisit some of the algebra that is problematic from last year, but is essential for you being successful in upcoming courses. So the algebra concepts that I like to focus on are multi-step equations, which we've already done quite a bit of that with the angle addition, segment addition stuff. Okay, it'll still be, like I said, pervasive through the entire course though. The second, which we're starting to investigate now, are system of equations. So this is algebra that is going to be used predominantly in our examples to practice our geometry. Okay, and then the third one will be what we call quadratic equations, which we will use what we call factoring. If you guys remember stuff like last year where we had the parentheses and put an x here and an x there and plus or minus something, that was factoring. That will be the kind of the third type of algebra that we focus on inside our geometry problems. But this will be something that we use all the time throughout the entire year. Okay, so if you are a person that struggles with systems of equations, I'm going to give you a tool right now that I hope that you use. Okay, if you're in Schoology, okay, inside each section in Schoology, so I'm just going to click on 2.6 real quick. If you click right here, Okay, every section through the entire course so far, I've built the entire course out, and each section is going to take you to my website. So I'm going to click that. Okay, now this is my website. Hopefully some of you have been to it. Now this is only the chapter 2 website. If you come up here and just delete out everything after the .com and hit enter, it's going to take you to the home page of my website. Okay, and this is what I use for previous years. So I've probably used this website, I don't know, probably 7-8 years. If you scroll down around all this stuff, okay, I think I showed you guys this in class with some sig fig things, okay, for your chemistry. If I scroll down here to this table, it's narrowed your scope of YouTube or Google for finding help with prerequisite skills for this course. So let's say you struggle with fractions. We'll click on this fraction. Sometimes it might be slow to load because I've got some interactives here created for you. But if you're a person that struggles with adding, subtracting, multiplying fractions, I've narrowed your scope, narrowed your purview for YouTube, and you can look at these videos and get all the instruction that you need and all the examples you need to be more proficient at working with fractions. Okay? Well, look underneath fractions and it's systems of equations. Okay? Now, systems of equations, I've got this broken down. I'll zoom out a little bit. Broken down to 2 techniques. Okay? Systems of equations using elimination. Okay? Or systems of equations using substitution. And if you struggle with either of these concepts, algebraically, all of these start with they've severed themselves from any geometric aspect. Okay, so all of these problems are going to be straight out of Algebra 1. They start with the equations and show you how to solve them. Okay, but you can go through these and you've got a lot of examples here that can serve your needs. Some other things that we'll work on throughout the year: radicals. Okay, we've got a lot of videos down here with radicals, simplifying radicals, adding, subtracting them, multiplying, dividing radicals, and rationalizing radicals. These are going to be key concepts that we have to focus on throughout the year. But again, the amount of time in class to teach the geometry and teach the algebra again from last year is going to be something that will be hard pressed to do. So if you struggle with those concepts, please take the time to look through these videos to assist yourself. Okay, there's a factoring as well when we get there. Some of these have little applets built into them that provide you kind of endless examples that you can practice. But if that's a resource that can benefit you, please take the time to use them.